All right, today we're solving linear inequalities. Linear inequalities. Um, couple things to know: the same procedures you use to do equations, we're going to do with inequalities. So we're going to act like they're equations almost, with one exception, and that exception is the inequality sign must be reversed when both sides of the inequality are multiplied or divided by a negative number. When that happens, you know you're going to flip that sign in the middle. Going to reverse the greater than to less than, or less than to greater than. That's the only change. Other than that, same thing as equations. So this one says solving graph. So I'm going to take the inequality and solve it just like equation. I'm moving the 2x over there, make it 5x minus 5 is less than 6. Move the 5 over there. That's going to be 11. Divide by 5, we get x is 11/5. And that's what it looks like when you solve it. Now when you graph it, could draw the number line. Going to put 11/5 on the number line. And because it says less than 11/5, I'm going to shade. I don't notice I got an empty circle because 11/5 is not part of the solution. If it said less than or equal to, I would color in my circle right there because it'd be included, but 11/5 is not included in my answer. So I'm going to shade the left-hand side of that, and there is the answer. Let's try another one like that. Same kind of deal. I'm going to move the 7x over here, make that 17x minus 4. And over here I have a 13. Move the 4 over to the other side, moving the 4 over there, get 17x is less than or equal to 17. That's convenient. Divide both sides by 17, I get x is less than or equal to 1. That's your solution. Once you graph your solution, I'm going to put a 1 on the number line. Yeah, kind of got to read this one a little backwards. First of all, it's just a filled in circle, but also the way you read it from the X. A lot of people try to count on with the way the sign is facing to figure out which way to shade. Not true. You got to read it from the X. It says X is less than or equal to 1, which is this direction. Okay, don't necessarily go with the sign. Now, you can go with the sign if your X is on the left-hand side, but if it's on the right-hand side, you really have to read the problem to figure out exactly where you need to shade. And you should have done those skills before. All right, find the domain. Remember, domain means what can X be or not be. What values can it hold? So a square root has to be positive or equal to 0. It can be 0, but it can't be negative. I should have said it cannot be negative. So what I'm going to do is I'm going to take what's in there, bring it out, and say, okay, x minus 6 has to be greater than or equal to 0 because it can be 0 or equal to 0. And then I'm just going to move these 6 over. X is greater than or equal to 6. And that's your domain. We're going to write it like we always have. We're going to say all x such that x is greater than or equal to 6, and x, of course, is real. Or you could also do this if you like interval notation better. You could always write it like that. That's a lot quicker if you like that better. Okay, the second one. Anytime you have a fraction, remember you cannot have a 0 in your denominator ever. Also, because you have a radical down there, it must be positive. So down here this time, I'm going to say this. I'm going to say, okay, 3 minus x must be greater than 0. It cannot equal 0 this time because you can't have 0 in your denominator. So what I'm going to do is I'm going to move the 3 over. If I move the 3, I get negative 3. Now I'm going to divide by negative 1. Don't forget, when you divide by negative, you must flip that sign in the middle. Make it x is less than 3. So your domain is going to be all x, such that x is less than 3. And of course, x is reals. Or you could do this right here. You could go anything from negative infinity up to 3 would work if you like that notation better. And this is quicker. And if you want to start doing that, that is absolutely fine. Okay, compound inequalities are when you have either an and or an or. This first one has basically 3 sides to the inequality. So basically what I'm going to do is I'm going to solve all 3 sides. I'm going to subtract 5 from all 3 sides. And what's going to happen here, it cancels, so it gives me 2x there. 2, and over here I get a negative 8. And then I'm going to divide all 3 sides by 2. I get x is less than 2 divided by 2 is 1. Negative 8 divided by 2 is negative 4. That's your solution. To graph your solution, I'm going to draw a number line. Put negative 4 over here because it's less than 1. 1 over here. Empty circle above the negative 4. Filled in circle above the 1. And because it says x is in between the 2, you shade in between. That's called an and. That's called a conjunction. An and. Conjunction is when you write it all together and you say the word and in between. So this number here is between negative 3 and 7. The second kind is called an or, which is called a disjunction. And basically, we're just going to solve both of them, both of the inequalities there. One thing I did notice right now, that's supposed to be a negative 7, so you might want to correct that right there. That should be a negative 7. So just going to solve each one of them. Move the 5 over here. It becomes positive 5, which makes it a negative 2. Divide both sides by 2, that's negative 1. So that's the first one. Or move that 5 over right there. 1 plus 5 is 6. Divide by 2, you get 3. So that's your solution. When you graph it, now this is a disjunction, which means a little bit something unusual is going to happen here. Negative 1, 3, filled in circle, empty circle. Now, x is less than 1 are the numbers over here. The numbers greater than 3 are the numbers over here. And that's what a disjunction looks like. When you graph an OR, your graph is going to go all the way to the arrows on both ends, and they're going to go away from each other instead of toward each other like the AND did. The conjunction right here went toward each other, the OR goes away from each other. And that's always going to happen with the ANDs and the ORs. One more problem. All right, for her house painting job, Erica can be paid in one of two ways. $250 plus $10 an hour, not bad, or $20 an hour flat. Suppose that a job takes n hours. For what values of n is plan B better? Which means for Erica, the better one is how does she get paid the most? So we want to know when plan B, you ready for this, is greater than plan A. So plan B is this. Plan B is $20 per hour. I'm going to do 20, well, I said n hours, sorry about that. So I'm going to make 20 times n. When is that greater than this, 250 plus 10 times per hour times n? So when is it greater? So I'm just going to solve it like we've been doing. Moving the 10 over here, that gives me 10n is greater than 250. If you divide by 10, you get n is greater than 25. So what that tells me is anything over 25 hours, she's better off doing this right here for Erica. Now, the customer would be better off doing that one, but for Erica to make the most money, anything over 25 hours, she's better off just getting $20 an hour and working it that way. So may do a couple applications like that tomorrow, but it'll be pretty easy to tell how to set them up, I think. No big deal. And remember, work inequalities just like equations, except if you have to multiply or divide by negative, then you have to flip that sign. I'll see you tomorrow. We'll work on them like we always do. See you then.